All right, welcome to part 3 of chapter 1. In part 3, we're going to start talking about scientific notation. Yes, scientific notation, and one of the things you'll find when we go through this, especially if you watch problems that I do, is that if you've been doing scientific notation for a long time, when you see the word nano, you think 10 to the minus ninth. When you see the word giga, you think 10 to the ninth. When you see kilo, you think 10 to the third. Centi, 10 to the minus 2. So going back and forth in scientific notation is going to be something you're going to need to be able to do. You're going to need to be adept at. So you really need to kind of know this table and take it to heart. Now there's some we don't use. We don't use hecto, we don't use deca, we don't use deci, but we do use centi. And we use centi because centimeter is a convenient unit. A centimeter is about the width of your finger. So it's a really convenient unit. Why do we use scientific notation? Because it makes life easier in the end. Because we're lazy. Because I can write 1.6 times 10 to the minus 19th quickly and know how many zeros I have in this. But if I write 0.0000000, 16, right? I mean that's ludicrous. It's going to take me way too long, and without scientific notation, it's hard for me to tell if I've even got the right number of zeros in there. Another thing that we use all the time in physics, and you really need to sort of be aware of and be ready for and be ready to recognize when we're doing this, we use the Greek alphabet. The reason we use the Greek alphabet is simple, really, really simple. If we used our own letters, our own alphabet, and alpha, by the way, alphabet, the word alphabet comes from alpha, beta, alphabet. When we say alphabet, we're really just doing nothing other than saying the first two letters of the Greek alphabet. So the reason we use the Greek letters is because if we didn't, we'd be reusing our own alphabet so much, and it'd be way more confusing than it already is. Even as it is, we use T for temperature, and we use T for tension, and we use P for pressure and for momentum. So we still end up reusing letters, but the Greek alphabet helps us in terms of getting away from using the same letter over and over and over again. There are a few things that you're going to have to remember, and you're going to have to remember all the time, because we're not going to make the assumption. We're going to make the assumption throughout this course that you know the circumference of a circle is 2 pi r. We're going to make the assumption that you know that the area of a circle is pi r squared, or if you give them the diameter, pi d squared over 4, or that the area of a sphere is 4 pi r squared, or that the volume of a sphere is 4/3 pi r cubed, right? You need to know these. You just need to know them. Last things, you need to know the difference between accuracy and precision. So this upper graph here, the strikes on this target, they're accurate. And they're accurate because on average they're hitting the center of the target. Down here they're more precise. And they're more precise because the grouping is tighter, right? The grouping is tighter. So accuracy and precision, two different things. You need to understand how to calculate uncertainty in things, and we're going to have some problems on uncertainty that you're going to have to do for the homework. Calculating the uncertainty, calculating how big that is, understanding significant figures, all right? You got to understand significant figures and what they mean. Now, when you're doing the problems online, the homework problems give you a certain margin of error around the answer. And unless I'm saying in the problems, use a specific set of significant figures, just plow through with your calculator, get to the end, and you should be within the margin I've set up on the problems. We can do approximations, and we do approximations all the time in physics because almost every time we do a measurement, it's an approximation. So we do approximations. Now sometimes they're very good approximations, but we're always doing approximations. So you'll need to understand what approximations mean. You're going to have some problems on this. And the homework sets kind of walk you through the problems. And we'll take a look at how the homework works here in a bit. The final thing, math. You're going to need to know some math. We're going to be using algebra all over the place. We're going to be using some trig, and we'll go over some of the trig, and there's a little trig review for you that you have to do at the beginning of the course. So yeah, math. Math is the language of physics. It is how we talk physics to each other, and it is important, very important, for pursuing this subject. All right, that's it for Chapter 1. Have a great day.